Let's consider the function f of x equals the absolute value of x cubed plus 6 x squared plus k. We're told that this function has two local maximum values, which occur at points a and b, where a is less than b. These values also satisfy the condition 3 times f of a equals f of b. Our goal is to find the value of k that makes this true. To begin, we look at the expression inside the absolute value. Let's define a new function. G of x equals x cubed plus 6x squared plus k. Then f of x is just the absolute value of g of x. To locate possible maximum or minimum points of f, we need to examine where g of x has critical points. Let's differentiate g of x. The derivative is g prime of x equals 3x squared plus 12x, which factors as 3 times x plus 4. Setting this equal to 0 gives us critical points at x equals -4 and x equals 0. We can identify the maximum and minimum using the general shape of a cubic function, but we can also confirm this more precisely by checking how the sign of the first derivative changes. In other words, by using the first derivative test. At x equals -4, the derivative changes from positive to negative, which means this point is a local maximum of g. At x equals 0, the derivative changes from negative to positive, so this point is a local minimum of g. Now remember, f of x is the absolute value of g of x, so the behavior of f depends on whether g is positive or negative at these critical points. If g of x is positive at a critical point, the absolute value doesn't change it. But if g of x is negative, the absolute value reflects it upward. So for f to have two local maxima, we need g of -4 to be greater than 0, and g of 0 to be less than 0. This means that the graph of g must cross the x-axis between these 2 points. Let's calculate the values. First, g of -4. That's -64 plus 96 plus k, which simplifies to 32 plus k. Next, g of 0 is just k. So we now have g of -4 equals 32 plus k. G of 0 equals k. We also know that 3 times f of -4 equals f of 0. Now, because g of -4 is positive, f of -4 is just g of -4. And because g of 0 is negative, f of 0 is the opposite of g of 0, or -k. So our equation becomes 3 times the quantity, 32 plus k equals -k. Distribute the 396 plus 3. K equals -k. Bring all terms to one side. 4k equals -96, so k equals -24. Therefore, the value of k that satisfies all conditions is k equals -24. This is the only value that makes the function. F of x equals the absolute value of x cubed plus 6x squared plus k. Have two local maximum values, with the smaller one at x equals -4, the larger one at x equals 0, and satisfying the condition. 3 times f of a equals f of b.